You know, the engine in your car is the result of this quiet revolution. A kind of secret war of materials that was fought in factories and labs. It's really the story of how engineers decided to abandon a century of tradition, swapping out heavy iron for a material that would totally redefine the cars we drive every single day.
So what happened here? I mean, for decades, cast iron and steel were the undisputed kings of the engine bay. So why the massive change? What problem was so big that it forced a complete rethink of the heaviest, most central part of the car? Let's get into it. At its core, the change was actually pretty simple. Over on the left, you've got the old guard, heavy, super durable cast iron. And on the right, you have the Challenger, lightweight aluminum. But don't let that fool you. This one simple swap set off a whole chain reaction of changes that would affect everything, from your gas mileage to how your car feels taking a sharp corner.
Okay, so here's our game plan. First, we're going to tackle aluminum's huge weight advantage. Then, we'll look at how it deals with heat. After that, we'll explore the manufacturing side of things. And finally, we'll see why steel didn't just disappear completely.
All right, let's get right into it with the number one reason, the single biggest driver of this entire revolution: weight. See, aluminum is incredibly light, and that one simple fact creates this massive domino effect that changes just about everything about how a car performs.
And it all boils down to one simple word: density. Just think of it like this. Imagine you have a box of rocks versus a box of popcorn. For the same size box, the steel is packed incredibly tight, but the aluminum is much more, well, airy. There's just less stuff packed into the same amount of space.
And that brings us to the magic number: 1/3. Yep, for the exact same size piece, aluminum weighs only 1/3 as much as steel. Just let that sink in for a second. We are talking about the heaviest single part of a car, and you can suddenly make it 66% lighter. That's not just a small tweak, that's a total game changer.
So, what does that actually mean for an engine block? Well, when you swap out a cast iron block for an aluminum one, you're not just trimming a few pounds here and there. No, you are slashing the engine's weight by 40 to 55%. That is a huge, huge difference.
And this is why it matters to you, the person behind the wheel. A lighter engine means the car doesn't have to work as hard, so you get better fuel economy and lower emissions. It also means less weight sitting over the front wheels, which makes the car handle better, makes braking more effective, and puts less strain on your suspension parts. Lighter is just better.
Okay, so weight is a huge deal, but that's not the whole story, not even close. There's another massive factor in play: heat. Because, an engine isn't just heavy, it's also a ridiculously hot furnace.
Think about it. Every single time a spark plug fires, you get a tiny, contained explosion that shoves a piston down. Now multiply that by thousands of times a minute, and what you've got is an incredibly powerful furnace right under your hood. And getting rid of all that heat efficiently is one of the most critical jobs an engine has.
And right here, this is where aluminum shows off its other superpower. This chart is showing us thermal conductivity, which is just a fancy way of saying how fast something can get rid of heat. And just look at that difference. Steel kind of likes to hold on to heat, but aluminum, it sheds heat 4 to 5 times faster. It's almost like having a radiator built right into the metal of the engine.
And having that superpower pays off in a big way. The engine warms up to its happy place, its optimal temperature, much faster. But it also stays cooler when you're pushing it hard, which helps prevent a really bad thing called engine knock. And because it's so good at managing heat, engineers can design engines with higher compression ratios. That means they can squeeze the air and fuel mixture tighter before it ignites. And that squeeze is the secret to getting more power and better efficiency out of the very same drop of gas.
All right, so we've got weight, we've got heat. But the third piece of this puzzle actually takes us back to the factory. Because, as it turns out, aluminum is also a whole lot easier to work with, and that opens up all kinds of new possibilities for engine design.
The key process here is something called die casting, and the secret ingredient? It's temperature. See, aluminum melts at around 660 degrees Celsius. Steel? Well, steel doesn't melt until you get it over 1400 degrees. That massive difference means you can work with molten aluminum almost like it's plastic, injecting it into these super complex molds to get incredibly precise parts.
I mean, the process itself is beautifully simple. You melt the aluminum down, you shoot it at super high pressure into a very detailed steel mold, and just a few moments later, out pops this nearly finished, incredibly complex engine block.
And for the car makers, the advantages here are just massive. You can create these really intricate internal passages for coolant that would be basically impossible with iron. You can even build other parts right into the block itself, which means fewer parts to assemble. And here's the real kicker for the accountants. Because aluminum is softer, all the final machining steps can be done 3 to 4 times faster. That's a huge savings in time, money, and wear and tear on all the factory equipment.
So at this point, you're probably thinking, wow, aluminum sounds perfect. It's lighter, it's cooler, it's easier to make, which, of course, leads to a pretty obvious question. If it's so great, why is there any steel left in an engine at all?
And this is where we get to the core principle of all great engineering. There's really no such thing as a single best material for everything. It's always about choosing the right material for a specific job, and every single choice involves some kind of trade-off.
Yeah, this table really lays it all out, doesn't it? You can see all of aluminum's wins right there in the left column. Low density, low melting point. But now look at the right column. Steel is way denser and has a much higher melting point. And that translates directly into raw strength and hardness when things get really extreme. They're not really competitors, they're specialists.
And this is where steel is still the undisputed king. The parts inside the engine that take the most violent, intense punishment, we're talking about the crankshaft, the connecting rods, they need incredible strength to resist being pulled apart and torn up. They have to endure millions and millions of violent cycles without breaking, and that's a job that only steel can handle. In fact, most aluminum engines still use thin steel liners inside the cylinders just because aluminum itself is too soft to handle the constant friction from the piston rings.
So, there you have it. The case is closed. It wasn't just one single thing, but this really powerful combination of benefits. The big push for better fuel economy made its lightweight absolutely essential. The never-ending quest for more power made its heat dissipation critical. And the constant demands of mass production made its manufacturing advantages pretty much unbeatable.
The aluminum revolution totally changed the internal combustion engine forever. But now we're on the verge of a whole new era with electric vehicles. And they've got their own set of challenges, like battery weight and motor construction. It leaves us with a really fascinating final question. What's the next material revolution that's waiting just around the corner?